Yes, very good evening students. Welcome to Aksharanal classes. This is Gafar sir, your physics faculty. Let's start our session for today. So today I'll explain about the multiples and submultiples of the topic. So these multiples, submultiples are very helpful for expressing the any unit. Understand? So that part today we'll learn. In the last class, we completed about how to write a unit, what is a unit, and how to write the unit, what is the SI units, and what is series unit. That part we have learned. Now today, I'll explain multiples and submultiples. Got it? So our topic is today is multiples and submultiples. Multiples and submultiples. Multiples and submultiples. This is our topic. So here, this multiple and submultiples are two topics. One is multiples is one topic, submultiples is one topic. So this is similar to mathematics. So this is similar to mathematics. Let's talk about first multiples. Here multiples is telling that multiples of 10. Understand what is this here? Multiples, submultiples means, the multiples means here what multiples we are taking here? 10 multiples. So you know 10 multiples. So if I take first one is 10 and second one is 10 multiple is, one more thing is what? 100, that is we call 10 square. So 10 square. So and multiples of third multiple is what? 1000. 1000 is we can write as 10 cube, and directly 10 power 6 and directly 10 power 9, 10 power 12. This is the way we will use multiples and submultiples. So, but here this multiple having names. Understand? These multiples will express with a name. The name is, first one is 10 means deca. 10 means what? Deca. So now 10 square means hectare. Hectare. What is mean by 10 square? Hectare. 10 power 3 means kilo. What is the meaning of the 10 power 3? Generally we call it is 10 power 3 means kilo. 10 square means hectare. And 10 means deca. And similar way 10 power 6 means mega. 10 power 6 means what? Mega. And similar way 10 power means giga. 10 power 9 means what? Giga. 10 power 12 means what? Tera. Tera. 10 power 12 means what? Tera. These are the names. How can you express this one? You will express this one as D, deca. 10 we can call deca. So that is simply will represent with D, and hecto simply represent with He, and kilo will just represent with K, and mega just represent with letter M, capital M. Mega represent with capital M, and giga represent with capital G, and tera represent with capital T. So this is the way the multiples will use the symbols. But where you will use this multiples in our daily life to express a physical quantity. For example, let me take mass. I am taking mass here. Mass is a physical quantity. Even length also physical quantity. How do you express the units of mass with the help of these multiples? I will give an example here. The example I am taking here, mass. You know mass measures in kg. Actually here kg, let us take any 9 kg 9 kg. What is this 9 kg stands for? Here 9 kg stands for that. Here 9 is as usual. But here K represent what here in these multiples? K represent the kilo. K represent what? Kilo. Which means that how many kilos here? 9 kilo means what is the meaning of the kilo? Kilo means meaning is K meaning is kilo. Kilo meaning is what? How much is the kilo value? 10 power 3. 10 power 3. So here kilogram. So this is the way the conversion is helping. To convert, the multiples are helping you. So finally, 1 kilogram is equal to how many grams? Totally 9,000 gram. So this is a way we will use here multiples. And let me take one more thing also for length. Let me take length units. I am taking here length units. I am taking here length units. If I take length, physical quantity, you know, kilometer. Generally, meter is a SI unit of length. You know very well. Meter is a SI unit of length. But let me take some value of length here. I am taking 12 kilometer. 12 kilometer I am taking. In this 12 kilometer, this 12 kilometer, this 12 is as well. It's a magnitude. Here K stands for again. How much is the value? K stands for what? K stands for kilo, right? So kilo means again 10 into 10 power 3. So but kilo meter is a meter. Finally, how many meters here? 12 into 12,000 meters. So finally, the 12,000 meters. Instead of expressing just 12,000 meters, instead of expressing as 12,000 meters, just simply we are telling that 12 kilometer. So finally, what is the conclusion you made here? The multiples are helping you to pronounce easy way. Okay, a bigger value we can express in a short way is further these multiples are helping you. Got my point? So that way, here 12,000 meters. To express 12,000 meters, it is very difficult every time, isn't it? Further, just simply we can say as 12 kilometers. In a simple manner, we can express the physical quantity with the help of these multiples. Got it, students? I'll give one more. The one more is let us take you might have seen in your laptops, in the mobile phones, the speed of the mobile phones nowadays we are measuring with hertz, frequency. So frequency, let me take frequency. Just simply frequency means number of vibration per second. Actually, frequency means what? Number of vibration per second. The units for the frequency are hertz. The unit for the frequency is actually hertz. Hertz is a unit for the frequency. So when you are talking about these units and about the frequency, generally this you can observe in your mobile phones, in your laptops, gadgets. Every gadgets having frequency. The frequency for the gadget representing the speed, actually representing the speed. So the speed of the processor. So your processor means inner core of the any gadget. So the processor speed we measure in hertz only. But have you can observe once on the they given some labeling as 1.2 kilohertz, 1.2 kilohertz or 1.2 gigahertz. This is the way they mention the speed, isn't it? So what is the meaning of this here? The meaning here, so for example, if you take 1.2 kilohertz, that K stands for again what? K stands for kilo. Kilo means 10 power 3, which means that 1.2 into 10 power 3 hertz, it means that many times it will vibrate in 1 second, that is the speed. And similar way, what about this 1.2 GHz, gigahertz, this is called giga. So G stands for, so you know, giga. Giga means how much here? Giga means 1.2 into 10 power 9 H. This is the way we will express the speed for the gadgets in gigahertz, terahertz. Sometimes this is represents as terahertz, THZ. So you know Robo movie. The Robo movie, we have a chitti, right? The chitti always, when we call chitti, it will always express its configuration as speed 1 terahertz, memory 1 gigabyte. This is the way it will represent. So here speed terahertz means 1 terahertz means T represents what here? 10 power 12. 10 power 12 and sorry, here 1.2 into, so the T means stands for tera, the tera stands for 10 power 12. So this is a way we will use this multiples to express in a short way. So expressing this 1.2 into 10 power 12 hertz, how it is, or else 1.2 terahertz, how it is. I think it is very easy to express any physical quantity when it is having higher order. Got it? So I hope you have understood how we are using these multiples. Let me go for submultiples here. Let me go for submultiples. I hope everyone you can write down. Better write down everyone here. Let me take out this here. If you have any questions, you can ask me. Will clarify you if possibility is there. I am taking out here. So let me go for another topic in this same session. Another topic is what? Submultiples. Let me take submultiples. Here submultiples nothing but 10 below values. 10 below means negative values or decimal points of 10 we will consider as here submultiples. So first one is submultiple is 10 power minus 1. So 10 power minus 1 here, 10 power minus 2, 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12. This is the way we have submultiples. But what is the name of this 10 power minus? This name is deci. The name of this 10 power minus 1 means what? Deci. Name of this 10 power minus 2 represent that centi. What is that? Centi. And next name of this 10 power 3 means milli. What is that? Milli. 10 power minus 6 means micro. 10 power minus 6 means micro. 10 power minus 9 means nano. 10 power minus 9 is nano. 10 power minus 12 is 10 power minus 12 pico. 10 power minus 12 is pico. This is the way we will give the names for this submultiples. But how do you express here? Deci. Deci means D. And here centi. Centi means C. And milli. Milli means small m. Small m. And micro, we have a symbol mu. we have a symbol for micro is mu, nano just simply with the small n, and pico pi. So this simply you can represent with small p here, small p represent pico. So here, but where we are using these symbols in our daily life, I'll explain with an example here. Example of submultiples. The first examples, the first examples, the first example let me take for length. This is the length. Generally, length units are meters. Length units for the normal general units are what? SI units are meters. So when length is a unit for the meter is a unit for the length, then how do you express this length in terms of what? Submultiples. You know very well centimeter. Let us take a length having 12 centimeter. A length having how much? 12 centimeter. So in the 12 centimeter, this 12 is representing the magnitude, isn't it? The 12 is representing the magnitude. The C is representing that centi, but centi means 10 power minus 12, which means that here 12 into 10 power minus 2 meters. That is your expression of what? 12 centimeter. Got my point? Now, so to express this a bigger expression, bigger term, by using the submultiple, easy way we are expressing. So 12 centimeter is equal to how many meters here? 12 into 10 power minus 2 meters. Okay? I mean, pronouncing this is very difficult, right? Simply 12 centimeter is shortly easy way we will express. And next, let me go for another. Let us take a volume. Volume I am taking. You know, volume units for the volume units are for the SI system is meter cube. Meter cube. But how do you express volume here? How do you express here volume? Even we can express in liters also. Volume expressed in liter, that is a practical unit for volume. Same volume will express in liters. So actually 1 liter of volume is equal to 1000 centimeter cube. 1000 centimeter cube volume. 1 liter is equal to how many centimeter cube? 1000 centimeter. Yeah, is it okay? But here, how do you express this volume? Nowadays, we will, purchasing the milk. And the milk packet, you will observe that milliliter. So 500 ml. This is the way you will observe the expression. What in this expression stands for? This expression stands for this 500 as usual. The 500 is as usual, but here M stands for what? Milli. M stands for what? Milli. So, but milli means what? 10 power minus 3, which means 10 power minus 3 liters is equal to 500 ml. So, 500 ml is nothing but 500 ml is nothing but 500 into 10 power minus 3 liters. So shortly we will express as 500 ml. But one more quantity also you can observe here in our daily life, 250 ml. What is this 250 ml? The 250 ml means 250, M stands for 10 power minus 3 and L stands for liter, which means 250 into 10 power minus 3 liter it is, and 90 ml. Okay, you have many times you have hear this sound 90 ml. What is this 90 ml? This 90 ml stands for 90 is 90 only. M stands for what again? 10 power minus 3. So that is the way we'll express the, we will use these submultiples to express the physical quantities. Got it? Here this is 90 ml. Better take down here. I'll give one more example by using another thing. Yeah, I'm taking here. So I'll use one more, to measure the sizes of the nucleus. We'll use very minute length values. So for example, size of the nucleus. Size of the nucleus. For example, this is a atom. This is atom. Inside the atom, we have a nucleus. So atom is actually it is not visible. In that we have nucleus that is absolutely not visible to you. When it is not absolutely visible, but how can you measure, how can you express the sizes of the nucleus and sizes of the atoms? So for that, we'll use very, very low values, less values. To use that less values, these quantities, these submultiples are helping you. For example, size of the atom, let me take 1 nanometer or else 3 nanometer length. The size of the atom is 3 nanometer. What is this 3 nanometer here? 3 is as well. So N stands for what? N stands for nano. Nano representing that 10 power minus 9 meters. This is also will express. Other way also we will express. You have blood cells, right? The blood cells, if you see this, blood report, for example, if you observe the blood report of anyone, they'll mention in the sizes of the tissues or sizes of the something after diagnosis. They will mention in mu. So, for example, our blood cell size I am representing with 4 micrometer. So, what is this 4 micrometer? 4 micrometer. So, what is this 4 micrometers? Here 4 is 4 only. So, but here micro, mu representing that micro representing that 10 power minus 6. Since we will write here 10 power minus 6 meter. So, that is the way we will express the length. Okay, that is the way we will express the length. So, I hope you have understood this thing. Let me give some other examples. And these multiples and submultiples also useful for converting one system of unit to another system of unit. I think you got it now how we are using these multiples and submultiples. Let me give some other examples to get better understanding. So now I will give the things here. I am taking this whole thing. I will give some other examples to get practice. Okay, can I take out? Yeah, I am taking out this. Now I will give some examples where we are using these multiples and submultiples. Yes, now I am giving this. Now, for example, so conversion, these are the conversion where you are using these multiples and submultiples. Let us give first, I'll give some length units. I'll give some mass units. Next, time, because these are the very important physical quantities where we are using in our daily life. So, for example, 1 meter is equal to how many centimeter? 1 meter is equal to how many centimeters? 1 nanometer is equal to how many meters? Next, 1 micrometer is equal to how many meters? So these are some examples. Next, 1 kg 1 kg is equal to how many grams? 1 gram is equal to, next let us take one more. 1 gram is equal to how many milligram? How many milligram? This is a conversion. So this mg you might have seen on the tablet slips. You see the tablet slips, back side of the tablet slips. If you will observe this mg. Mg means what? Milligram. This is enough. For time also, 1 second is equal to how many nanoseconds? How many nanoseconds? So this is a time conversions. Okay. Next one more also. 1 second is equal to how many millisecond? Millisecond. So let's find out now one by one. So 1 meter, you know. So how many centimeters? You know, centi means 10 power minus 10 power minus. Yeah, 10 power minus. Centi means 10 power minus 9 minus. So 10 power minus kada. So 10 power minus 3. 10 power minus 3. So when it is 10 power minus 3, divide with 10 power minus 3. Divide and multiply with 10 power minus 3. So when you divide and multiply this 10 power minus 3, this centimeter. Okay. I'm doing in a wrong way. Centi means what? 10 power minus 2 kada? Yeah, 10 power minus 2. So let's take 10 power 2 by 10 power 2. 10 power 2 by 10 power 2, isn't it? So here this 10 power minus 2 and this value will become here. Okay, now look, I'm doing here 10 power 2 by 10 power 2 by 10 power 2. So but here 10 power 2 and this 10 power minus 2 I can write as, look at here, into 10 power. This I can write as 10 power 2 into 10 power minus 2, isn't it? 10 power minus 2, because I have written this 10 power 2 as 10 power minus 2. Here 10 power 2 as it is. Now meters. 10 power 2 is equal to, this 10 power 2 is nothing but I can write as centimeter. So simply cm. So finally, how much is the value you have? 10 power 2 centimeter. Okay. Just look at here. I have done here a mathematical manipulation. What is that mathematical manipulation? The mathematical manipulation here is I multiplied and divided with 10 power 2. When I multiply and divide with 10 power 2, this 10 power 2, if you cancel it, you will get the same thing, isn't it? So, but here 10 power 2 as it is I have written, but 10 power minus 2 I can represent as 10 power minus 2. This 10 power 2, it is in denominator. When it is come to numerator, it can write as 10 power minus 2. But 10 power minus 2 you can express as centi, right? So finally, how much? 10 power 2 centimeter. That is the way you can express. Now look at here, nanometer. Nanometer is equal to how many meters? So here nano stands for 10 power minus 9 simply. So 10 power minus 9 meters is equal to 1 nanometer. So this is also 10 power minus micro, mu stands for micro, 10 power minus 6 meters simply. So this is the way the conversion. Coming to the kilogram. Kilo, look at here, kilo means 10 power 3 and 10 power 3. Isn't it 10 power 3 and 10 power 3? So when it is 10 power 3, the 10 power 3 I can express as a 10 power 3 only, but 10 power denominator 10 power 3 I can represent as 10 power minus 3 grams. But here this 10 power minus 3 I can express as a milli. So 1 kg is equal to 10 power 3 milligrams. So this is the way we can express. Even this is also. So where have I did any mistake? Yeah, I did a mistake. Simply I done a mistake here. Yeah, the mistake is here. The kilo, this kilo, right? Kilo means 10 power 3. Simply I can represent 10 power 3 into gram. So simple way. No need to multiply and divide with 10 power 3. No need to multiply and divide with 10 power 3. But coming to here, 1 gram is equal to how many milligrams? So here 1 gram means how many milligrams? Milli. So you know, milli stands for what? Milli stands for 10 power minus 3, right? So 1 gram is equal to 10 power minus 3 milligram. So this is the way we can express the values. I hope you have understood what I explained. So for today, children, you enjoyed the session it seems. So now I'll stop the session. Based on this concept, you can try some questions from the material. For today, I'll stop the session. Until then, bye bye.